Okay, good evening, guys. We have some problem we want to solve. Actually, these problems are on polynomials. I bet you've not seen it. These are not the usual polynomial problems. You can see them. This is like number 1. This is number 13 here, number 14, number 15, number 16. You're seeing it. And then we have it down to 17 here. And then you have 18. So, but the way we're going to do it is that we give it different videos so that it's not going to be bulky. Do you understand what I'm saying? We don't want to scare you away. That's it. So let's go right to it. Let's go right onto it. The first one here, prove that the equation ax squared plus into a minus 1 with x. So this is the leading term. That's the leading term, the quadratic term. Of course, it is quadratic equation. That is a linear term. And this is the constant term equal to 0 as real roots for all values of a. That is, for every values of a, it has real root. And then once we are done with this part, this is a different part, and find the values of a if the sum of the root is thrice or 3 times the product. You're seeing it? The sum of the root is 3 times the product. Let's go right on to it. We provided the solution not to waste your time. Now, the first one, this is the equation they gave us. They said we should prove that it has real root for all values of a. So we said, okay, if it is for all values of a, 2 things. A can either be 0, although this understanding will not make sense, because someone will say, if a is 0, definitely it loses its definition. That is the leading term here. Let's care about the leading term. Forget about the linear term. Forget about the constant term. The leading term is going to be 0, because 0 times x squared is going to be what? 0 squared. Actually, that's 0. So meaning it loses its term. But let's see. That is, because they said for all values of a, they never put a restriction. They should have put a restriction in the question. They did not put it. That's why we take care of every possible situation. Do you get what I'm saying? Now, okay, look at this. If a equal to 0, that is, this part is going to be 0. This part is going to be what? Because it's going to be 0 times x squared. That is 0 squared. That's off. And then this will be 0 minus 1. 0 minus 1 is what? Minus 1. Minus 1 times s, that's minus s. And this place is going to be what? 1 minus 2 times 0. 2 times 0. 2 times 0. Now, 2 times 0 is what? Somebody said, God bless you. 2 times 0 is 0, and that will be 1. So that is how we got minus x plus 1 equals 0. Obviously, we can bring minus 1 here, and then bring in minus 1 here, 1 equal to x, x equal to 1. That's the first situation. And we said, which is a real root. Like this root, root of an equation is what you get by setting the equation equal to 0. So once we set this equation, the given equation here, we set the guy equal to 0, we got 1. And 1 is a real number. Yeah. So that is a thing. One of the situation. Find the root for all real values, for all values of a. So one of the roots we got here is 1. Okay, let's check another one. What if a is not equal to 0? That is, a can be negative, it can be positive, it can be rational, it can be anything. So far it is still a real number. Now we want to compute the discriminant. Why do we do discriminant? Because discriminant is what tells us the nature of the root. If you're able to get a positive discriminant, then we say that the quadratic equation, either positive or 0, has real root. In fact, if the discriminant is 0, it has one real repeated root. That is, it will be one number that will repeat itself. Something like if you are solving x squared plus 4x plus 4, the root will be what? Minus 2 and minus 2. So let's compute the discriminant of these. And you can try it. The discriminant of x squared plus 4x plus 4 is obviously 0. Try it yourself. The formula for the discriminant is given here. The discriminant of a quadratic equation is given by what? B squared minus 4ac. So we wrote it out here. Your A is always comparing this one to the standard quadratic equation. You know the standard quadratic equation, which is what? Ax squared plus, the standard quadratic equation is ax squared plus bx plus c ax squared. So this is the standard quadratic equation. A is going to be a here, that's a quadratic term. B is going to be a minus 1, that's a linear term. C is going to be the constant, 1 minus 2a. That's the constant term. So that's how we got A equal to A, B equal to A minus 1, C equal to 1 minus 2A. So computing it down, B squared is what? B is A minus 1 all squared minus 4 times A times what? C, 1 minus 2A. That's what we did here. And then we expanded this. It will be A minus 1 times A minus 1. Of course, if you do that, you get A squared minus 2A plus 1. Expanding this led to this. Now, minus 4 times 1 minus 4A. Sorry, minus 4A times 1 minus 4A. Minus times minus plus 4A times 2A. 8A squared. So collecting the items, A squared plus 8A squared is what? 9A squared. Minus 2A minus 4A minus 6A plus 1. And then when we solve this quadratic equation, it led to what? 3A minus 1 all squared. Now, we said, okay, if we set this whole thing equal to 0, if we set the discriminant equal to 0, we can actually say setting the discriminant equal to 0 or setting the result we got equal to 0. Both will satisfy each other. So when we set this thing equal to 0, of course, we want to know what 8A will be, so that we substitute it here to see if the statement, if the conclusion we are coming about with from this process is actually the same as we doing the equation normally. So when we set this one A equal to 0 here, what do we get? Of course, you know that A is going to be 1 over 3. Now, with setting A equal to 0 is the same as saying setting the discriminant equal to 0. Now, if the discriminant equal to 0, it means it has real roots for all values of A, real repeated roots for all values of A. But that's what do we make? How do we make that claim? How do we justify the claim? The claim we made. Now, to justify it, we actually did a proof here. Now look at it here. We substituted A into the equation. You can try it too. We substituted A into the equation and then we solved the system. It led to 1 and 1. Meaning that what we concluded there's going to have one real repeated root. X equal to 1 is a real number. And don't forget, that was what we got when we set A equal to 0. Mathematics will never lie. We don't lie in maths. We tell you the truth, fact, the gospel truth. That's the thing. So look at it here. We get X equal to 1 and 1. Justifying our first claim for A when A equal to 0. And equally justifying the system that says that we are going to get one real repeated root. And this is a real number. So we conclude that if A equal to 0, let's come back here. So our conclusion is that if A, for all real values of A, we have real root. For all real values of A, this A here is a real number. Of course, you know that. And then we get a real root, which is what we got here to be what? Of course, you saw it there. 1 and 1. That was a real root. Now, the second part of the question. I want to take you back to the second part of the question. Now, the second part of the question here. Find the values of A if the sum of its roots is 3 times the product. We want to find the values of A which satisfy that condition. Of course, coming back to this place, find the values of A when the sum is 3 times product. 3 times its product. What is the sum of root? Of course, sum is actually what? Alpha plus beta. If you remember, yeah. If you don't have any issue with this, you can comment, drop it in the comment section, then we can actually make a video to that respect. Now, the sum of root is actually alpha plus beta equals to what? Now we know that is minus b over A. Minus b over A. So already you know in this equation, our B is what? Our B is A minus 1. Our C is 1 minus 2A. And our A is A. So that was what we did here. So minus B over A, that will be minus A minus 1. Minus into bracket A minus 1 all over A. Minus times A minus times minus 1 plus 1. So we brought the positive before the negative. We have what? 1 minus A all over A. And then the product. The product is what? C over A. You know C is what? The linear part, 1 minus 2A all over A. Now, but the conclusion here is that the sum is 3 times the product. The sum, that's why we showed here. Alpha plus beta is 3 times product. Sum, 3 times product. So what is our sum? What we get for the sum is what? 1 minus a all over a. And what we got for the product is what? 1 minus 2a all over a. So the sum is 3 times the product. From here, when you have two fractions, and then on either side of the equal to, the denominator can cancel the denominator, numerator can cancel the numerator. So if they are the same, and if they are multiples of each other, you can divide the usual division. So that will be what? We are left with what? 1 minus a equals 3 into bracket this. So this is going to be 3 times 1, 3, 3 times minus 2a minus 6a. And then we collect the like terms. Are we together? So we brought this one here to this side and this one to this side. So that's minus a plus 6a. Are we there? And then 3 minus 1. So 5a equals to 2. A is going to be what? 2 over 5. 2 over 5. Please note the situation of, since we've showed you already this part, a equal to 0 is not something we should consider. Note that, because if you consider a equal to 0, then it will chop off the quadratic term, making us have a linear stuff. And for the linear term, you can never get the sum of root of a linear term, because it's only going to give you one root. It is if it is quadratic and higher that you can tell me you want to get the sum of your root. Do you understand? So a can never be 0. So this situation should be excluded. So the only situation you should consider is when a is not equal to 0. So somebody will say, when you know it's a situation we should exclude, why do you include it? It's because they said for all values of a, you need to try everything. At the end of the day, you now tell us, okay, I've did it all. You told me to do it for everything, but for this particular one, it shouldn't make sense. So don't do it, because it will lead you the wrong way. Do you understand? So that is the solution to the question 13.